Hi, I'm Rob Taylor for Tuts Plus, and in this video tutorial I'm going to show you how to build a professional looking video slider like this one out of open source hardware, which should run you around $100 or so and is very easy to put together. I got this hardware from OpenBuild's parts store. There are other similar sellers around the world, particularly Makerslide Europe and Australia, which sell a similar aluminium extrusion with built-in V profile. Now I'm assuming you know what a video slider is and what it does and when you would use it, so let's jump straight in. Okay, so before we jump straight into the build itself, I want to take a look at some of the parts and tools required for the build so we know what we're getting ourselves into before we start. The foundation of the whole thing is this aluminium extrusion. It's called V-slot. It is black anodized for, I suppose, professional looks, and it's very lightweight and very rigid, so it's perfect for our uses. It's, on top of that will go this gantry plate right here. It provides the mounting point for the fluid head. Cheap fluid head, picked it up at a yard sale, like $3, something like that. If you have a more expensive fluid head that you have spare, then use that, obviously. But the gantry plate, fluid head on one side, wheels on the other side, and then the whole thing mounts loosely onto the slider. The wheels themselves are all of these. There are 6 of them. Each wheel holds about 5 pounds or so. I have the Delrin wheels rather than the steel wheels because they're quieter. You can see it has, I don't know how blurry that will be, but it has a double V profile. It runs along the V profile of the extrusion. Each wheel comes with that tire, 2 smallish bearings, a little washer to space the bearings through the center of the wheel, and bits of mounting hardware. Those wheels will be mounted under 2 spacer blocks, each with 3 holes in, 3 wheels per block, which will go directly between the wheels and the gantry plate. These will provide a little bit more room for us to get under the plate and maneuver the machine screws that hold on the fluid head as and when necessary. At the end of the V-slot track we have these 2 bolt-on end stops, essentially, is what I'm using them as. What they actually are, if you can see the circular part, they are for mounting motors, pulleys, things like that for automation, which will be the next stage of this when I add motion control to it with stepper motors and that kind of thing. All that remains here is just the various bits of hardware, machine screws of different lengths, specialized T-nuts that fit into the V-slot for mounting stuff to it, special offset nuts for, or spacers rather, for mounting the wheels so that we can adjust the exact width of them to the rail and adjust the tension and wobble of the plate moving along it. We have these double T-nuts used for mounting 2 sections of V-slot together, which you may have noticed over here. I'll be looking at modularity a bit later on in the video. And that's it on the parts. So onto the tools. since we need to mount quarter 20 both machine threads and tripod socket plate, okay, so onto the tools. Since the V-slot system is metric and we need to mount a tripod plate to the two endpoints so that we can adjust the height and angle of the track, and we need to put these quarter 20 machine screws through the center of this gantry plate, we need to open up these holes from M3, M5, that kind of region, to the full 1/4 inch diameter. For that, obviously, we need a drill and some drill bits. Use decent quality drill bits for drilling metal. I have titanium something or other, fancy ones. To cut off these machine screws to the appropriate length, they're 1 inch long. Not very much use because the fluid head would be floating well above the gantry plate. We're going to use Dremel, cut off wheels, easy. While we're cutting and drilling, obviously workpieces mounted in a vise, and for the cutting and drilling, WD-40 as a cutting fluid. Now, the one tool that most of you are probably less likely to have is tap wrench and taps for cutting 1/4 20 threads directly into other materials. Now, on these end caps, I don't want to have the tripod fitting onto here and then the thread poking through and then another nut onto the top of it. I just want to screw the tripod head directly into the unit itself. So I'm going to tap it. Whichever way you do it is up to you. Now, I believe that's it. So let's start building. Okay, so we've moved to the shed and we have our vise set up on a table saw for a base. I will just use a regular taper tap, which is the type you start off with. It's not too aggressive in its threading towards the end to allow it to more easily cut through the metal without risk of snapping. Just simply line it up, make sure it stays vertical. The tool steel will happily cut through the aluminium, no problem. Just make sure it stays vertical until it's got a couple of threads in there, and then just keep twisting. Once you can see it's all the way through and it's no longer offering any resistance whatsoever, you can just bring it back out. Rest it on the thread inside there for extra stability. We're drilling directly through the hole in the very center, right there. And this time it is not the same size as the drill bit, so we do have to drill. Okay. Cutting fluid inside and around. Some more on there. Alright then. make sure it's all lined up. Okay, so we have our gantry plate in our vise and the 1/4 bolt going through it. I want to cut it off after around 3 threads, which seems to be the norm for quick release plates. I've found, got the Easy Lock cutting disc in the Dremel. And we'll bring it to a moderate speed. Hold one side of it, count 3 threads back, Okay, so we're back in the house. We have our modified parts complete and we are ready to move on to assembly. This should be fairly quick and straightforward because it's literally just screwing stuff together. I think the first thing that makes sense to do is to produce the 2 complete spacer assemblies with wheels ready to go onto the gantry plate, and then that can all go together with the fluid head. To do that, we need our 6 V-wheel kits. There is a new version of the Delrin V-wheel which has a single V profile instead of a double V profile. That may be useful if you're using heavier cameras. We need our 3 eccentric spacers for adjustment on the other side. Obviously we need our 2 spacers, and because we're using the spacers we also need our 45, I believe, millimeter machine screws. I'll double check that and make sure it's in the written parts list, exactly what all of this is and the specs of all the hardware. So let's get started on the wheels. I'm going to do the 2 spacers simultaneously so you can see how I'm doing each one differently. The real difference, the only difference between the 2 is the type of wheel spacer I'm going to put on each side. On one side I'm just going to use the regular symmetrical spacers that come with the wheel kits, and on the other side I'm going to use these eccentric spacers which have the hole drilled off center so that you can actually move the wheel back and forth simply by rotating this spacer. These fit inside here, and the spacer with the eccentric spacers will go on the side of the gantry plate with these 3 large holes right here, and the spacer with the 3 regular spacers will use 3 regular size holes on the other side. So let's get started. We'll push our bearing into the wheel, pop in our little washer right there to space through the middle, and we'll put our we'll start to put our other bearing in, but before we go all the way through, we'll grab one of the bolts we're going to use, because we're not using the kit bolts, and put that through in order to make sure the washer inside is lined up with the center. So that rotates nice and smoothly, so we can take that out and throw it on the floor and move on to the next 5 wheels. Okay, I just rescued that wheel from the floor. Now let's move on to the next wheel. Again, nice and simple. Wheel, bearing. First one side, and then it might be easier just to put the bolt straight in, and then the washer, and then the other bearing, and press it all together. Okay, second wheel done. Okay, now that we have 2 wheels put together, let's start mounting the spacers and getting this all together so that you can understand what's going on at each side of the gantry plate. First I'm going to do the side with the regular spacers. I'm going to take one of my longer bolts, which are longer than the kit bolts, in order to accommodate these extra spacers that I use. I'm going to put that straight in through the top of the gantry plate, like so. And then I'm going to put this spacer on, and then I'm going to put this spacer on. Then I'm going to put the wheel on, and then I'm going to finish off with lock nut. So that's the order on one side. On the other side, we take our large bolt through the large hole, through the spacer, eccentric spacer, make sure that slots into the large hole in the spacer block, then the wheel, and then a lock nut. And that's our general pattern right there. Regular spacer, eccentric spacer for adjusting the distance between these 2 wheels, essentially. And we can continue this all the way down. Okay, wheels are in, lock nuts are on, symmetrical spacers down one side, and eccentric spacers down the other side. I'm currently in the process of locking in the 2 spacer blocks with these in between bolts. I'm using the small machine screws on the threaded holes within the spacer blocks. All the machine screw heads are the same size, it's just a 3mm Allen key. So you just screw it in, and you're done. Now, to tighten up the lock nuts on the wheels, I'll just be holding the machine screws with the 3mm Allen key and using a socket wrench with a 5/16 inch socket on it, and just ratchet that into place. Not too tight. When it starts tightening up, start to go a little slower. The tighter it is, the more it's going to bind those bearings up, and you don't want the wheels to be tightened up that much. You want them to be running freely. Okay. None of those are too tight. Check that all the wheels turn okay. That one's a little on the tense side, so I'll back it off a little bit by reversing the direction on the ratcheting wrench. That one's okay. Yep, all the rest are fine. So that's the wheels done. Now it's on to adding the fluid head. To make this a little bit easier on myself, I'm going to remove the handle so it's not trying to lean all over the place. And then I'm going to put the cut-off bolt, the 1/4-20 bolt, through the bottom of the gantry plate. There we go. And then I'm going to start turning it onto the fluid head, and once that's caught I can line up the direction I want the fluid head to be oriented in, probably that direction, and then I can grab my stubby little Phillips head screwdriver and tighten it down. There we go. Okay, wheels on, fluid head on. That's basically the whole dolly part of the slider complete. Now, to get the end cap onto the extrusion rail, the first thing to do is to add the T-nuts that will hold it onto the rail. We just slot those into the rail, nice and easy, because obviously once we have the end cap on the rail, it'll be very difficult to add them at that stage. So we can just slide them into the extruded V-slots, one for each of these holes right here, and then the same on the other side underneath. Now to pop the cap onto the rail, it fits quite tightly, it doesn't go on, it doesn't just slide on. So what I do is I put my thumb knuckle between the two pieces and then rotate my thumb, which forces them far enough apart that you can get them on. And then just line it up and start adding our short 6 or 8mm machine screws. You can grab the Allen key to help line them up through the holes. Okay, the ends are on, the gantry's in place, I added the handle, and it runs pretty smoothly. The only thing left to fix before it's ready for mounting and using is this little wobble right here, where the wheels underneath aren't quite fully indexing into the V-rail. That's very simple to adjust. We just flip it on its side so we can see the eccentric spaces, and then we turn them until all the wheels are fully indexing. Give give that a try. Still slightly wobbly. If all the spots are facing in the same direction, then all of the wheels are exactly the same distance from each other, from side to side. Okay, let's see how that goes. Now there's zero slop from side to side. See what the friction is like. Some, not too much. You could probably back it off slightly if you wanted a smoother system. Let's try that. There we go. Now at this point you should have your completed slider looking something like this, with one of these end pieces at each end. Ooh, there we go. And a nicely smooth moving dolly platform in the center with the fluid head on top. That was pretty simple, so let's go out and test it and see how smoothly it operates. Well, I hope you enjoyed this tutorial and can see how easy it is to build a slider that's surprisingly equivalent to the over $500 versions. There are various improvements and variations that can be made. Feel free to experiment. And that's it. Thanks for watching.